This video is going to explain BJTs, so bipolar junction transistors. We're going to talk a bit about their function, what they are, how they work, schematics. Basically, transistors are used for one of two things, switching or amplifying. We'll touch on both briefly, but primarily switching here. Up till now, we've worked with a device called PN junction, right? Where we have doped material, leads have been attached, and by applying voltages to it, we can actually control the polarity, or we can make this forward bias or reverse bias depending on the polarity of the applied voltages. Well, transistors aren't all that different. All that's happened with a transistor is we've added in this piece down here on the bottom. So we've now sandwiched an extra layer. So you have PNP, or of course the other option would be an NPN. And that gives us, now we have two depletion regions, or there's two areas. You know, there's one through here, and there's one here. So there's two spots that there's a depletion region, or that there's a joining of the P and the N-type material, which gives us a bit more control over the current that flows through this. It's not just on or off. We can kind of get something in between on and off, and that's how we do amplification. Of course, on and off is how we do switching. So it's sort of like a transistor or a diode we can switch. If I were to sort of want to explain or show you schematically what this looked like, if you were to use it in a schematic, of course we have to show all three leads, so they look something like this. Now I mentioned there was two types. There's what was called the P and P, or the other one of course was the NPN. These are in many ways the exact same thing, the only difference being polarities, of course, right? If you had a diode, the difference between a PN and an NP is just polarity. On a PNP, this would be your schematic, and PNP, I like to remember to saying pointing in please, meaning that the arrow points in, and of course current flows in the direction of the arrow. And PN, being the opposite, is not pointing in. So its arrow is here, and it points out. Those are your two basic transistor types. If you look at sensors and electronic devices, you'll see PNP and NPN used quite frequently. On these devices, we have three leads. The three leads are emitter, base, and collector. And it's exactly the same here. Emitter, base, collector. And again, for both of these, this trend is also true, that the current flowing in the emitter is the sum, or is the total, of what's flowing on the base plus what's flowing in the collector. So all current flows on the emitter, and base and collector currents are added up to make emitter current. If I were to try and draw this on my little picture here, that means that in this case, current flowing out here, let me redo that. Alright, there. All the current flows in here, and either comes out the base, or continues on up and out the collector. This one would be the same idea. It either comes from here, out the emitter, or this way. But again, you'll notice all the currents flowing through the emitter, and the base and collector are summed to come up with the emitter current. If I were to sort of draw these out, there's three real states we can look at. If we looked at the two junctions like I was talking about before, we can say that there's the first junction would be the collector base junction, right? And the other junction that would be available would be the base emitter junction, right? So again, what I'm saying is there's two PN junctions here, and these are the two of them. And there's three states that are available to us. So you can imagine if I take this collector-base junction, and I could put the right voltages on there, I'd be able to make it forward biased, or reverse biased, or somewhere in between. So if I were to set this up and say I want it to be reverse bias, I just put the right voltages on there and I get a reverse bias here, right? And base emitter, I could set it up that it would be reverse or forward. So you can see I got these options. The other end of the spectrum, of course, would be I set up voltages that forward bias this and forward bias this. And these should be pretty straightforward to you. That would mean that in option 1, when they're both reverse bias, nothing's going to get through, or we refer to this as cutoff. There is no current flow through the transistor in this scenario at all. The other scenario at the other end here, where it's forward biased, that's a piece of wire, so we would just be calling that saturation. And of course, this region in the middle here, we could set up a reverse forward, which means we now have a bit more control over, we can move it between cutoff and saturation. We can control it between these two, or control the current flow. If we were amplifying, this is considered the active region. So looking at the transistor's function, if we go and set up some biasing, or we set up a circuit, we can set it up so that it's in cutoff, it's in saturation, or it's somewhere in this active region. If we're using it as a switch, of course all we need is cutoff and saturation. The switch is closed or the switch is open. If we're using the active region or as an amplifier, then we need to be a little more careful on how we bias it. And in a future video I'll talk about that one in more detail. Again, if I were to sort of draw out an expanded version of one now, here, right? If I drew it out here and I said that, I don't know, let's go with the arrow going this way, which was which, remember? That was a PNP, right? Pointing in, please. If this is the case, what I'd need to set up then, if it's PNP, I need to set up bias voltages, or voltages that give me the right signal. So I need to have a negative here, and relative to this negative, I need to have a positive here, right? That gives me biasing, or sets up biasing in this circuit. And then again, I can set negatives and positives here, and as long as I'm careful on what all these voltages are set for, so as long as this is more negative than this, the collector is more negative than the base, and the base is more negative than the emitter, we can set it up to be in its active region. In other words, current can now flow through here and have this reverse bias, and by changing this voltage on the base here, we can move it between cutoff and saturation, right? So once we get a bias set up, we have the ability to sort of vary the base current very slightly and have really big variations in collector emitter current. That's called amplification, and there is a linear relationship, and we'll be talking about that more in future videos.